Hey everyone, let's do example 2, number 41 from the book. So we're looking at fake Twitter accounts here. Looks like we take a random sample, what I assume to be random, of 46 accounts. Right, so that means that the degrees of freedom equal 45. We have a sample mean of 14.1, and we have a sample standard deviation of 9.6. Okay, so we construct a 90% confidence interval. Then what we do, right, we find the margin of error, and then we just add and subtract it from the sample mean. Okay, so the margin of error is going to equal our critical value times s over root n. And that's going to equal, well, in this case, since the degrees of freedom are 45, we don't actually have that. Remember, we round down to the nearest one. That's 40. And if we're looking at 90%, we get 1.684. And then we just compute this divided by this. Do it in a calculator, it turns out to be approximately 2.38. So our 90% confidence interval is 14.1, right, our sample mean, minus 2.38, and 14.1 plus 2.38. Right, and that's really when you just do the subtraction out. Just to be clear, that's a comma right there. That winds up being 11.72, I believe, to 16.48. I believe that is what we get. Okay. Now for part B, is it reasonable to conclude that the mean percentage is less than 10? And the answer is no, because 10 is below our 90% confidence interval. Now, if you want, you could say, well, 90% is not strong enough. You could try a 95% confidence interval if you want. But generally speaking, if a number's outside the confidence interval and it's a reasonably high percentage, then we say no, it's not reasonable to assume that that's the true mean percentage.